This is Don Brill. Here I am again making yet another video on another version of the rice huller that we made it compact. After this intro, you'll see me go right into how to build this out. I wanted to go over a few things. We have the website ricehuller.org that a gentleman named Dave Taylor, who's a website developer, volunteered to build the website and support it. Just wanted to go over a few other things on that. I've written these extremely detailed instructions on how to build it out, and that I think will have a PDF that you can download, or some way that you can print these out. In the video, I say that the screws, one of the screws is number 8 by 1.5, it's 1 1/4. These discs are 36 grit. The shaft collars that we use inside the Piranha rollers are 1 1/8 in outside diameter, 1/2 inch for the inside. You'll see how we assemble that. The other thing would be is that if you were in the process of building it and you need a little bit of advice, my email address is djbrill@aol.com. So now we'll get right into building out the rice huller. I've redesigned the rice huller using these Piranha rollers. The dimensions on the sidewalls and these are now 5 by 7, and if I take all of this, including the base, I can put all of it into one of these medium-sized UPS boxes, which means it could be shipped anywhere in the United States for about $20. So the idea is that maybe out there someone would be willing to start building these for people, because I always get a request. Maybe I'll do it, but we'll have to see. Now let me run a little rice through and then we'll slowly take it apart. I've already done some here, and I was getting 90%. And basically, this is how we do it. This controls my feed up here. These are sandpaper sleeves. You could put a motor on this, and if you do, have it run at around 500 RPM, maybe 600. But this is about the rate we're going to be doing it at. And your arm will get tired, so that's why we hooked them up to bicycles in the past. But you can easily do half a pound for that dinner. As it turns out, rice stores really well as long as it has a husk on it. And then once the husk is off, it starts to degrade. So that's basically how this works. I'm putting it on very little load. You'll get 90% already. Okay, let's open this thing up, see what we've got. Try to get this in position so you can see this. So this is 5 by 7. I use 3/4 inch or 1 inch plywood. You could use regular pine and make the sides out of that. So a 6-inch is really right around 5 1/8, 5 1/2. So you could use that. I would suggest you do pilot holes or through holes, because when I tried solid wood it split. So 5 by 7. We're using a 12mm shaft now, so the bearings have to match the shaft. And the reason we had to drop down to this metric was because the diameter of our roller is so small, the other bearings would be as wide as the bearing itself, so you couldn't actually get it to work. So we have our 12mm shaft, matching bearings. We're using number 25 chain, smaller, so that everything will fit. And on this one is a 12 tooth. Over here is a 24 tooth. These are idlers. This is a 12mm bolt with the nuts that go with it. We have the this is a 20 tooth, I believe, idler. This sprocket here is what, 25, 20 tooth idler. So as you can see, this one has twice as many teeth as this one. For our gap setting, we now have one on the top, one on the bottom, because I couldn't get one here in the middle and we want to keep it uniform, which allowed us to drop down. These are just a shelf bracket, right angle, that has a hole here and a slot on this side, which allowed this to move a little bit in case these aren't perfectly aligned. This is the typical winch handle. You can drill this out to 12mm, put it over the shaft, put the 2 collars on it, and drive a bolt through here, maybe 2 bolts. In this case, I took my grinder cutoff wheel and I shaped the shaft itself. And then when I take it off, you'll see that. Over here, I've added this brush. This is a very cheap paintbrush called a chip brush. Turns out that the static charge on here, the husks would start coming over and maybe they interfere with our hulling rate, so we got rid of those. Turn it around this way. This is our feed. So we've got number 25 chain, 19 tooth, they're both identical, so they're both, so whatever this turns at, this turns at. We're using our setup here. The spring here comes out of 3D printers. You can buy the whole kit of a set of springs because they are not uniform, so you pick the one that you believe will work. This down here is my aluminum. I make these notches with a saw. That way it gives me more ability to adjust it. Over here, inside of here, these are sandpaper sleeves, 1 inch in diameter by 1 inch long, which is 3 inches. That matches my rollers. Now I'll take this apart. So I'm going to start taking this apart. I misspoke. These boxes are United States Postal Service, not the UPS. Oops. So we have the winch handle. This is the one I was saying that you could drill this out to match this 12. What I did was, as you can see, I just ground this down so that this would slide on here and then put a collar on either side. These are our idlers and sprockets. One thing when you go to do this, this all has to be perfectly aligned. There's not a lot of space in here for misalignment. So if you're off, it'll start skipping a tooth here and there. which is problematic, but that's how you solve that. This is the 12, the 24. I've undone these screws that were here are gone. This side is the one that stays. Turn it around this way. This is the, these have to match. They don't have to be 19. They could be 20 or 15. I've loosened the screws on the bearings. I've taken these nuts out, so this side is no longer attached to this side. I can now, actually this is the feed hopper. It's no longer attached. This is the part that slides. And again, I have a brush on the back here doing the same thing, pulling the husk off. Here's the slide. Okay, now I'm going to remove this half and you'll see what's on the inside of this. Let me keep this. This is just my plexiglass. Two things, I can see what's going on and it stops rice from popping out of the pinch point area. Let me get this off of here. So hopefully you can see this. So this is my brush. It sits like this. I just have it flexed. This is a shelf for that to go on. This is just below the midpoint so that this brush is at the midpoint. This is my angled plate here. Underneath that is a wedge. I only attach things to this side just to make it easier. So this goes from 0-ish up to 2 inches on this side, 4 inches, and this gives me that angle. This base plate is 7 by 10 3/4 because I want it to fit inside that cardboard box. This is our roller. We take these with a shaft, and I'll put in the video how I do this. I basically use a 1 1/8 inch diameter shaft collar that's forced into here, and then there's a little bit of a cavity on either side. You roughen these ends up and you put epoxy in there to lock the shaft and the rollers together. So this is all now, let's see this here? This block of wood here is because I get this rice popping out. Sometimes it doesn't get grip, so it pops out with the energy. So this block is on there to keep them from coming back onto the outside of the pin. So let's take apart the sidewall. We have the drive sprocket. So in here, this is the gate. This is what allows the rice to come in. Pretty straightforward. You just cut a slot here so you can lift it up. If you need more height, you just remove more from the slot. This right here is the well where the rice sits. This is critical that this be about a 1/2 inch wide. If this is too close, rice spills over the top. This piece here that comes on, this is adjustable. It's got a couple of slots in it that allow me to slide this forward and back until it just clears these pieces of sandpaper sleeves. So this is in the middle of the rollers. These are our rollers, the feed roller. So this is the 1-inch pieces. You can just buy these like this. And then I have 3 of these shaft collars that lock in like this. So this is below the surface. This is extremely straightforward. There's not much else to tell about this. Just get them in there. Now remember that we're going to be putting on the a flat here for the screws. So we put a flat on each end. One thing that I did fail to mention was this material here. It's an 1/8 inch thick. What it does is it matches the arc of the roller. So I no longer attempt to get this roller aligned perfectly with this. I leave a gap, and then I don't want rice falling in the gap, so I put this on it. It just makes it so much easier, because sometimes these things are just not exactly, and one thing you never want is this roller rubbing against here. One time I did it with a motor. It softens this and then it sticks to the plate, and I had to work pretty hard getting everything apart. So we have the shaft, 12 millimeters. We have 2 of these 3-inch brushes. We have the bearings. We need a total of 6 of those. These are 1/4 inch nuts and bolts. This is all wood that was just cut. We have a wing nut here, 1/4 inch bolt going through here. This hole in this wood is a 1/4 inch or a little smaller, so that it can just be threaded in. This is my plexiglass with the right angle elbows. Here's all of the sprockets and idler for that drive side. Here's the feed roller, these 2 sprockets. It's our winch handle. It has 2 of these collars. Each one of these has 2 shaft collars with an outside diameter of 1 1/8. The inside diameter will be 1/2 inch, which is larger than 12. So I take tape, duct tape in this case, and wrap it around the shaft until it reaches a 1/2 inch diameter. Then I put them on, and they're about this close on each end. Then I roughen it up, the roller, and put this epoxy putty in there. This shaft needs to have a groove cut out, a slot for the epoxy to grip, because this is very smooth, so the epoxy may not grip it. Also, you're going to grind out on here spots for the bearing, the screws in the bearing to go into. You need to make flats, and then you'll also make flats for these. If you don't make flats, it'll either not grip, or it'll start to slide in there, make a scar, and then you won't be able to get things off. Here's our 12-inch shaft. These are collars with a 1-inch outside diameter, 1/2 inch inside diameter. So on the shaft, I just put tape on there to build it up, and then use these shafts or shaft collars that aren't split. These just go right in. Then we have our collection of screws. These are number 10s that are 3/4 inch long, and these are number 8s that I believe are 1.5 inches. That way I can attach through the plywood. Over here, these are the springs that you get this kit, and you say, well, why can't I just buy these? And if you can, this was the blue one that we were using, and if you can find it, you could do that. The reason that we're using these number 8 bolts is because they'll go through the ID of these. So this again is the number 8 bolt that's 2.5 inches long. On here, these are nuts that have the plastic insert to keep them from loosening. I would suggest you just go ahead and buy a bunch of these and then use them at all these spots rather than trying to use lock washers. This is our 12 millimeter by 3 inch fully threaded. You gotta make sure you get fully threaded bolts with the corresponding nuts and washers. That should do that. There's a hole in the wood. If you don't have a 12 millimeter, you can use a 1/2 inch because these get locked down pretty tight. This over here is the base, the plexiglass window. This is the shelf for the brush. This is the foam. This is probably maybe 5/16 thick by 3/4 inch, so it very nicely, as they come together, it keeps the rice from spilling out. Again, this is one of these little arcs I have here to keep rice from going in. These are the countersunk bolt heads so they don't interfere. So these are the parts. I'll put at the end of the video some of me earlier making these. Secondly, I would suggest if I were doing these, I would just take these look like they're about 1 foot long, and just go ahead and center them, and then when you're done, cut the ends off. Because on some times when I do this, one side will be too short. Well, let me show you this. This is a bracket that I got on Amazon where it's round here with a slot here. This slot's a little bit big, so I had to use washers because they are what I used here. But you can see I had to pack it out with washers. I still prefer my 1 inch right angled aluminum where I cut out the slots. I've taken one of the sidewalls. What you're going to do is take one of them, do these holes, then use it as a template for the other ones. This one has the slot and this hole for the idlers. You won't be making these in the other sidewalls, just this. The key is that once you make this first one, the others all need to match it so that the pinch point between the rollers is aligned. So you're going to draw a line here that's parallel to this line, 1 inch in. Then you're going to come across here at the bottom, 2.5 inches down. At this center point where these two lines come together, you position your bearing. Then hold the bearing and drill out these 2 holes. These are 1/4 inch, or at least that's what I use. And then here at this center point you're going to do this 3/4 inch clearance hole. Over here, this is for the idlers. You're going to come down 1 inch over 1 3/16 and do a 1/2 inch hole, or if you have a 12 millimeter bit, you can do 12 millimeters, because that's what these are. Here is the slot. The center of the slot is 1 1/4 inches from this edge. It's 2 3/4 inch long. The bottom of it is 1 inch. So you start here 1 inch, go up 2 3/4, notch this out with a router or cut it out however you see fit. It is a 1/2 inch wide or 12 millimeters. Once that's done, like I said, you take it and lay it on top of the other ones, and then you drill out these holes. Now on the back side of this, you need this clearance hole, which is 3/4 diameter. This is 3/4, and what these are countersunk, so that the bolts will drop below the surface. So because of this head here, we want this deeper than that. That's all it needs to be. You can use a speed bit to go in there. Speed bit might self-align. Now for the hopper. This is the same size as our sidewalls. So you take a bearing, set it on there, hold it, drill out these holes, do the clearance hole. Again, you have to have these countersinks. Then you put it over the top of the other one, use it as a guide to make out these holes. Here's our gap setting assembly. So these are the rollers. They are not going to be aligned perfectly. So you rotate them, and you want to leave a slight gap, very slight. You should be able to see light coming through as you rotate it, and then you make it so that it just has a slight opening. The roller itself will give, and these springs will also let it move out. So you're going to assemble this. Now I'm going to show you why I use the notches. When I use the notches, I'm able to put this in and then pull these in and out. So I can put this in and then put this in like this. One way to make this notch is to drill a hole down here and then cut it out with a metal cutting blade. I happen to be able to cut these out fully with the blades I have. If you don't want to do that, you can use these right angle brackets, which I'm sure will work. It's just less convenient, but for somebody who's only going to build one, you might just get the right angle bracket. This one has the slot in it, and it's a little bit big. So here, this one has to have the plastic insert. This is the one that you actually turn this one to set the gap. Then once you're where you want to be, you want to get the compression on these springs to be equal. So you want them to be the equal amount of compression, so that should be the same. When I build it, I actually have the shafts in there and I pull on it and see what it is to pull on it, and especially with the chain on, I pull on it and make sure that it will allow rice to fall through if it goes all the way open. Another thing I wanted to point out is we're making these flats on the shaft, and that's for these small screws that hold the bearings in place, and that also will hold the sprockets, keep the sprockets from turning. My suggestion is that you pick an edge here and you grind out, this is about an 1/8 inch wide, from here all the way out. Do that on both sides. They don't have to match where they are, but at least you'll have one flat for your screws. Sometimes I had difficulty putting one here and one exactly counter to the other one, but our loads aren't that high, so one nice flat spot all the way out. Just a tip. We have this, the diameter in here is 1 1/16 inch per their instructions. So these black couplers, this one is a 2-part. When it is set on a 1/2 inch shaft, there's little gaps here and here, it fits nicely in here and will center our shaft. So what we have to do is take our 12 millimeter shaft and add something to it to make it a 1/2. And what I'm going to be adding is just some tape. So I've marked on here where the roller is going to go. And I've also mounted it in the huller so I know where the grinding should have taken place. These shafts that I bought are for linear transmission. So these are case hardened, and if you have a file, it's harder than the inexpensive files. You can't cut it with a hacksaw. The only way I can cut it is with one of these abrasive wheels. It's a cut-off saw, and then once you have this, you can remove the metal where you're going to put the screws for the sprockets, and then right here, if you can see that, I cut notches out because we're going to be putting epoxy in there and to keep this thing from spinning. So it's going to be going in here like this. Now for the epoxy is going to go on here, but I want to make sure it sticks here. So I'm going to take this drill, this is like an 1/8 inch bit, and I'm going to just punch some holes, making it easy to center this. The only reason we're doing this is to make this easy to center onto our shaft. This is the idea, is that we want it nice and tight. So I have a mark here, a mark there. We need to go down just a little bit more. And again, when you've done this, you've made this pretty precise. So now I'm going to fill this cavity here with the epoxy, and I don't even actually have to fill it all the way. What I'm using for that is some of this epoxy that comes in a putty. If you're watching this, you've watched the entire video right up to where I dubbed in some video that I had done earlier of putting the shaft in here. If you are making one of these, good luck. Go to the website. There's links on there where to buy the different parts. Right now, I don't know that the website has these two here, which are off the feed roller. This is, both of these just have to be the same teeth, number of teeth. Everything's based on this number of 25 chain. Good luck.